Kiebler, Ed from Rottler, hearing Doug Yates talk about you saved his dad a lot of time. Like, and as someone who I think about my dad, like doing something 6 hours and then it takes 45 minutes. That's what you're trying to do for everybody.
That's correct. That's one of our goals at Rottler. That's the only business that we're in is the automotive engine rebuilding business or the performance business. So we're constantly trying to innovate and make our product better, more efficient, and allow the shop owner, as we talked earlier with Joe Creason, it's all about what I call billable hours. So if a 2-man shop can bill as many hours a 3 or a 4-man shop can, there's going to be better profit for them, hopefully. And so that's our goal is to try to make this equipment more user-friendly. Even though it's higher technology, it's user-friendly and create better productivity in the shop. And
Doug just said it, and it's all a competition. I mean, we're all friends. We all try to improve, but it's all a competition. These people that are in business, there are other businesses. They're trying to get ahead. And any innovation, and back in the day, they would look for innovation in all these different places. Any innovation that could help them get ahead, they would adopt. And that is true for what you do. That's what you're helping shops do. Innovate, get ahead, create more time.
Absolutely. If the shop is more productive and makes more money, they're going to buy more equipment. And that's our end goal is our customers are partners, and we try very hard to bring a quality product to them that gives them or allows them more productivity and to make more money.
And the idea that there are machines around the country and around the world, frankly, operating, and he said it, lights out, 24/7, making parts and pieces for many different industries. There's got to be a sense of pride in that, too. Like, as you watch the whole world evolve, knowing that you guys are a part of it.
Yeah, absolutely. And unfortunately, I'm going to date myself here, but I've been in the automotive industry for 47 years now. So I've seen innovations that I never dreamed possible. Doug talked about he honed his first motor at 13 years old. Well, I probably didn't hone my first block until about 18. But I look at today to where you have a piece of equipment that you can push a button and walk away, and it will hone all 8 cylinders within a couple of tenths to the exact surface finishes you need, unattended while somebody's doing something else. I would have never dreamt that possible.
Which is amazing. And I wanted to ask Doug, but he kind of touched on it, and so I'll throw it out there to you. To get to where we are now is amazing. Like you said, I would have never dreamed, right? But someone has to dream. And it's obvious that thinking to the future is part of this business. And so what do you see out there 20 years from now?
Well, that's an excellent question. I won't be around in another 20 years probably.
Oh, that's not true.
Our big, what I tell everyone is I travel across the country throughout the year, and it is so important to get your customers involved with your company. And one of the big reasons I travel around the country and visit customers is to get their input and find out where their challengers are at. If we can meet their challenges, then we're a successful company.
Well, that makes a lot of sense. Clearly a successful company, and we're just getting started. This thing is going off pretty well. We've got a worldwide audience. They're participating. They're sending in questions. They're chatting with each other. They're all becoming friends in the chat room. Like, did you expect that it would happen like that?
No, I didn't. When we undertook this endeavor, it was just almost on a whim. It's like, we don't have a trade show. What are we going to do? Let's try this virtual thing. And thank goodness that we were lucky enough to get guys like Lake Speed and Chris Straub and the Joe Creasons and Randy Neal at CWT and all of these people to help us, because without their help, this would have never happened.
Well, it's tremendous, and again, we are just getting started. Keep on rolling with your questions in the chat section. We definitely appreciate that, as much interaction as is possible. As you know, that's part of the trade show deal, is the interaction with people.
Absolutely.
And we've been talking a lot about cylinders and honing and surface finish considerations, so why not have a look at one of our videos where we go a little more in depth in this area. So you've been hearing about it, now check it out.
Hey everybody, I'm Ben Strader here from EFI University, and thanks for being at this part of the Engine Performance Expo. I'm here with a couple of buddies of mine. I got Ed Kiebler from Rottler, and I got Keith Jones from Total Seal Piston Rings, and we're going to spend a little bit of time talking to you about the surface finish that you want to have depending on a number of variables in your high performance and racing engine. There's a lot of things that happen that will affect what you actually want that cylinder to look like. So Keith is kind of the resident expert in the what we want, and then Ed and I will pitch in and talk about how we might get that. But Keith, tell us a little bit about why the surface finish is actually important. Why does it matter?
Well, it's the gasket, it's the seal, and we're going to take a pause on that because somebody didn't mute their cell phone. Now, it was Ed, so no big deal. We'll keep rolling on because this is good stuff. What's changed over the years, I mean, we're all dealing with engines, we're all honing, we're trying to, we're using the hone to get the cylinder to a certain size. We're trying to achieve good bore geometry. We want a true, straight, round cylinder, but we also want to get a cylinder finish. And the whole point of that cylinder finish is to retain oil. As Lake Speed, who's behind the camera right now, so eloquently said, the oil is the gasket. This is the seal. The rings don't ride on the bore. They ride on the oil that's retained by the bore. This is the critical part of achieving good ring seal. We as a ring manufacturer strive to produce the best possible part we can within all the means and technology that we have. But the ring is part of the system. Cylinder finish, piston, ring groove, wall, proper tuning, all of these things are part of that soup. They're part of that mix. And if we don't get the recipe right in that soup, we are not going to achieve the ring seal that we need. The ring can only do so much. I mean, face it, folks, it's just a piston ring. If we make it flat, it's round, it's light, tight, what more can I ask it to do? It's doing its job. It can't fix a screwed up bore finish. It can't fix a bad piston. It can't fix a bad tune-up. We, as I like to say, and I haven't said it in a while, we are the redheaded stepchild of the racing engine. Well, I shouldn't say racing, any engine for that matter. Going down the road, flat tire, must have been a piston ring. Ran one over. It's always the ring. So with that said, getting these surface finishes correct are going to help to assure that that part of the mix is there for the ring. And what's changed so much over the years is the cylinder material. We generally will look to its cylinders and measure them in Burnell hardness. We've got, we'll say, the old days of a typical small block Chevy, small block Ford. You're looking at Burnell numbers 150, 160, relatively soft stuff. We were dealing with piston rings, 564s, 3/16. I mean, you have compression rings that made between 5 and 7 pounds of force per ring. I mean, folks, we've got oil rings that are lighter than that today. Yeah, for sure. The oil rings back in those days were in the 20s, 22, 24, 25. Hugely high tension rings. So with that said, we'd go in, we'd hit it with a 220 or a 280. We didn't care about the finishes because guess what? The block's soft. The rings have got a mountain of tension. Rings would fix the finish.
So Keith, would you say that that's why in the old days it was a huge endeavor to try to get an engine that would last, say, 100,000 miles? Like, they were pretty much worn out back then by the time you got there.
Oh yeah.
Now we have way better materials technology in the block. The rings have less tension, but we're still getting the oil control and cylinder sealing done. So do you think that's one of the major contributing factors to why our engines last longer now?
Absolutely. We're dealing with much harder cylinder surfaces. We're dealing with production engines today that have got block hardnesses well into the 200s. We're dealing with race applications that have got cylinder hardness numbers in the 300s, sometimes into the 500s. Very, very hard cylinder materials, which do make it a little bit more difficult to achieve the finishes, but we'll touch on that here in just a moment. But the overall material technology, ring-based materials, the coating technologies, the oil technologies, all of these have advanced so far that we're now, I mean, it's disappointing if you only get 250,000 miles out of one. And that's on one oil change.
Yeah, exactly. So what is it that's so critical then about the texture of the surface, and why wouldn't I just want the same surface if some is good, more is better? I mean, if I got 10 different engines, I want to try and get them all to the same surface finish, or are they all unique and individual? So let's talk a little bit about why that surface finish matters and why it changes based on my needs.
Absolutely. When we're looking at surface finish, we're talking about measured numbers. We're talking about RPK, which is the peak roughness. This is what the ring actually will come into contact with on a cold start. We've got the RK. This is the roughness below the peak or the mean center line. This is basically your bearing surface. This is what is supporting the load. The ring is trying to push its way through the oil film. The pressures behind the ring are trying to punch that ring through the oil film, just like a bearing on a crankshaft. If we don't have enough volume, we don't have enough pressure on that area, the bearing is going to push its way through the oil film and go metal to metal. Same thing happens with the ring. The valley, the RVK, the area below the mean center line, this is your oil trough. This is what holds the oil. This is what I like to call the tooth or the rung on the ladder. It's what gives the oil the ability to cling to the wall and hang on to it. Just because we're throwing the oil up there doesn't mean it stays there. The rings are trying to do everything they can to put that oil back down into the sump. It's this mechanism, these measurements, that are going to leave the proper volume of oil on the bore.
So now, Keith, I'll interrupt you. You said these are measured numbers. So are we talking about stuff they do like NASA at the International Space Station, or can like an average everyday guy measure these numbers?
Absolutely. We use a tool to measure these called a profilometer. And
Blake just happens to have one.
we just happen to have one. Thank you, Lake. Let's see if Lake's good. And it's even charged up.
Unbelievable.
So what we can do with this is come in, simply run it over the surface. You're going to laugh, folks. We're going to hit it right now. We're going to measure the whiteboard. Here's the profilometer. It's running that surface.
So what's hard to see is that little needle, looks like a little record player needle, is actually dragging across the surface of the whiteboard right now. And as there's little ridges and peaks and valleys, it falls in there, you know, like one of those things that measures the strength of an earthquake, right?
Absolutely.
And you get all done and you'll have measured numbers. Now you have data.
We have measured data. And as you can see, Ben's whiteboard has got an RA of a 25, and we'll explain that a little bit. It's got a peak roughness of a 17, not too bad. It's got a core roughness of an 84, but it's only got a valley roughness of a 29. So this thing's not holding any oil.
It's almost like I honed it.
Yeah. So this one's kind of pathetic, but you know, trust me, we've seen worse.
Yeah, I bet. Yeah.
We have absolutely seen worse.
So where's the guy? What is that thing worth? Where does the guy actually get one? Is that something an average shop guy could have, should have?
Yeah, this is a Mitutoyo SJ210. There's a lot of profilometers out there, folks. There's Federals, there's Mars, there's Zeiss. I can run a list as long as my leg. These things range in prices from about $500 to well over $100,000, depending on what you want it to do.
So what level you're racing at?
It all depends on where you're at. You want to get into 3D metrology and look at some of this stuff, you've got to have an optical profilometer. We're talking really big numbers, but man, there is some sweet data that comes from one of those. But one of these can typically be had for in and around the $2,000, $2,200 range. Not to be a commercial, we do sell these at Total Seal. We set them up. They're ready to go when they go out the door. So you literally just need to hook it up, use it, and run it. And this is available to anybody, from the novice to the expert builder. And now we've taken the guesswork out of this. We know what the numbers need to be. We're very good at it. We'll help you and give you suggestions of where you need to be based on the application. But this is one more thing that's no longer being guessed at. I like to say that I port one of the prettiest cylinder heads you've ever seen, till that tool called the flow bench proves me wrong.
That's right.
It may look great, but you want to knock 20, 30 horsepower out of your jump, you put some of my heads on, because they don't work, but they look beautiful. The point is, when we're honing cylinders, you can have an absolutely gorgeous looking cylinder. But we're talking microns here, people. We're talking micro inches. These are very, very small cuts. 5/10, 2/10, 6/10. It's very easy to create a good looking cylinder. You've got the scratches, they're there, but are they the right scratches? Do we have a deep valley? Do we have a relatively low peak so it's not hard on the ring when you first fire it up? As we saw here, this, not a good cylinder finish. Maybe great for a whiteboard, but certainly a bad cylinder finish.
So in your job at every day at Total Seal, how often do you get a phone call from a guy that says, man, I don't know what happened. I bought these new rings. I took my engine block to XYZ machine shop, and they just did it the same way they've always done it, and they told me they've been doing it this way for 30 years, never had any problems. All of a sudden, I put these new rings in, and it's got very low time on it. The rings are all burned up. What's wrong with your rings?
I get that call daily, multiple times, and it's simply, again, we're back to that redhead stepchild thing, and we're talking about, I've got this problem, and it's perceived as a ring problem, and I don't want to say every time, but most of the time, it's a cylinder problem. They just simply didn't get the finish numbers that are required for their application. We can guide you down those paths, but some basic numbers for what I'll call 90% of what's out there. Your street car, bracket car, circle track car, mild vacuum, mild boost, mild turbo. You're talking RPK numbers, your peak roughness numbers in the middle teens, 14, 15, give or take a little bit, it's a window. RK numbers, your core roughness numbers, you want to be somewhere, let's call that in the 40s, 35 to 45, kind of a window, little here, little there, not really going to hurt you. RVK, your valley depth, you want to be somewhere 40s, 50s, call it 40 to 55. It's a window. We want to be in that right area with the right proportions. We want to try to get the RK about 10 points below the VK. That just helps everything come in faster. When we achieve proper cylinder finish, one of the calls I'll get outside of the guy having the problem is, man, I'm on the dyno. I'm on my 18th hit. She's really coming in now, man. The vacuum numbers are coming up. My blow dye numbers are coming down. That tells me everything about it. Cylinder finish is off by a mile, and or he may have put a very, very slippery oil in there because during the break-in process, we need some friction. The rings are the final honing step. They are as good as we can get it on the best machines with the best tools, with the best operators. The rings still do the final job. So the closer I can get it to here, the faster it's going to come in. As Ben can testify, you know, this man lives on the dyno. 2-3 hits, you're in. This is it.
If we start an engine up these days and it's more than a couple of runs and it's not settled down, then we know something's wrong with it. And, you know, that's from a lot of some trial and error, but a lot of like calling you guys. And this is kind of what I was getting at is going, well, what are my targets? You know, where do I want to be with the finish? Because the reason that we kind of got into this whole honing game, you know, we have a engine program here where we do true R&D and then we use part of that for our training curriculum. But what I was running into was I would go to the machine shop and I'd get my blocks back and I'd go, it's not working, it's not right. And the machine shop guy would say, well, I've been doing it this way 30 years and nobody complained. And I would say, did any of those guys measure? Because if you don't measure, you got nothing to complain about, right? And so what happened was all of a sudden I was seeing this huge inconsistency. It started with our performance and it went back to, well, it's inconsistency in the cylinder finish. And it went to, well, how do I know? How do I measure it? So when you get to the level of your shop where you're building enough engines that you're spending and you're investing in tools and technology, I mean, a $2,000 tool is not the end of the world to be able to know. I mean, what's the cost just administratively and the headache of having to deal with a mad customer or fix their problem or whatever because the cylinder surface wasn't right? But one of the things I think you guys are always fighting, and Ed, you'll probably share a lot of this in your presentation on how to get what we want. Because right now we're talking about what do I want? Right. I didn't know I was supposed to want anything. Now that I want it, how do I get it? But what happens is the old kind of traditional machine shops that have been around, they're using vitrified stones with X amount of pressure for X number of strokes. But if I do that, I mean, if I'm just taking my stone and lapping a piece of material, if that material is harder or softer, that's not going to produce the same finish every time. And so that's how we ended up into the whole like diamond CNC honing game and talking to you guys about rings. And I mean, I don't know how many sets of rings we've gone through on, you know, 4 engines in the last 5 years dealing with you, but it's a bunch. Some I tore up and some I was just done with and some actually worked out really good. But my point is that if you're not measuring this stuff, having a conversation about what it should look like is almost irrelevant. Would you agree?
Absolutely.
And so I think what you're getting to is here's what these numbers mean. This is what peak is. This is core. This is valley. Now that we're starting to understand that, and I'm sure you'll go on, but we want to start looking at, well, okay, now that I know what the difference between a peak and a valley is, what do I want them to be? So you got a 95% rule, you know, be the teens here, be the 20s and 30s here, 40s and 50s there. That works for a lot of guys. But what about the guys that doesn't work for? So what are some factors you use to talk about like, okay, you're going to need, say, more valley or more peak? Talk a little bit about those situations.
Absolutely. One of the conversations we like to have at Total Seal, and we're one of those companies that welcomes your phone call. We're not going to try to just, you know, blow you off. We want to talk to you. And the first thing I ask literally every customer, what are you doing? What is this application? What do you expect out of this engine? Okay, is it a 0.72 millimeter competition eliminator engine with 20 inches of vacuum? Or is this twin turbo LS making 2,000 horsepower on the 85? Yeah. We have to fine tune that cylinder finish based on application. So if I know that I've got an engine that's running copious amounts of fuel through it, very high temperature, more than likely very easily washing out the cylinder and killing the oil film, I'm going to ask for that valley number to go up. I need more oil trap